Hello friends, welcome back. In this tutorial we will study about deadlock prevention. In previous tutorial we studied that deadlock occurs when these four conditions hold, right? So for a deadlock to occur, each of these four conditions must hold. These four conditions are mutual exclusion, hold and wait, no preemption and circular wait, right? Now we can prevent the deadlock to occur by ensuring at least one of these condition cannot hold, right? Now see the first condition is mutual exclusion, right? Now there are some resources which are non-shareable, right? Non-shareable resources must be accessed mutually exclusively, right? For non-shareable resources, mutual exclusion condition must hold. Whereas there are some resources which are shareable resources, right? For shareable resources, there is no requirement of mutual exclusive access, right? And these shareable resources cannot be involved in deadlock, right? So what happens, we cannot prevent deadlock by ensuring that this condition mutual exclusion does not hold, right? Because some of the resources are non-shareable resources, right? So for non-shareable resources, mutual exclusion condition must hold, right? So we cannot ensure that mutual exclusion condition cannot hold, right? Another condition is hold and wait, right? So to ensure that this hold and wait condition doesn't hold, right, we have to ensure when a process requests a resource, then it does not hold any other resource, right? So what happens to ensure that this hold and wait condition doesn't hold, we have two protocols, right? In first protocol, what happens, whenever a process starts its execution, right, then before starting its execution, the process will request all the resources which it requires for its execution, right? And these resources will be allocated to that process, right? So in this protocol, what happens, each process before starting its execution, that process will request all the resources which it requires for its execution, and these resources will be allocated to that process, right? Now let us see the second protocol which will ensure that hold and wait condition cannot hold, right? This second protocol, in this protocol what happens, the process is allowed to request resources only when it has none, right? So in this case what happens, if a process needs some resources, right, then before requesting the resources which the process requires, it has to release all the resources which has been allocated to that process, right? So in this case, a process is allowed to request resources only when it has no resources with it, right? Now the third condition is no preemption. Now how we can ensure that this condition cannot hold, right? For this we have two protocols, right? So to ensure that this condition no preemption cannot hold, we have two protocols, right? Let us see the first protocol. According to first protocol, what happen if a process is holding some resources and requests another resources which cannot be immediately allocated to it, then all resources which the process is currently holding are preempted. So in this case what happens, suppose there is a process P and this process is holding two resources A and B, right? And it requests another resource C, right? And this resource C is not allocated to this process immediately, right? Then what will happen, these two resources A and B which process P is holding, they will be taken away from the process P, right? Now let us see the another protocol which will ensure that this hold and wait condition cannot hold, right? So in second protocol, what happen if a process requests some resources, right, and the resources are available, then if the resources are available, then these resources will be allocated to the process, right? But if these resources which the process has requested, they are allocated to some other process, and that process which is holding these resources is waiting for additional resources, right? Then the resources will be preempted from waiting process and they will be given or allocated to requesting process, right? So in this case what happened? Suppose there is a process P, right? And it has requested some resources A and B, right? And there is another process P2 which is holding these resources A and B, right? And process P2 is waiting for some additional resources. Then what will happen? These resources A and B will be taken away from process P2 and they will be allocated to process P, right? Now if process P requests some resources A and B, right, and these resources are available, then these resources will be given to process P, right? Now what happens? Suppose process P is requesting some resources, right, and these resources are not available, right, and these resources are not allocated to any waiting process, right? So there is no waiting process which is holding the resources which are requested by process P. In this case what happened? This process P will have to wait. Now see the fourth condition, circular wait. How we can ensure that this condition, circular wait, cannot hold? So for that we will assign a unique integer to each resource type, right? Now we have two protocols to ensure that this circular wait condition cannot hold. According to first protocol, what happens? Each process can request resources only in increasing order, right? Suppose there are three resource types, R1, R2 and R3. Integer associated with the resource type R1 is 1, integer associated with resource type R2 is 2, and integer associated with the resource type R3 is 3, right? And there is a process P, right? Then this process can request resources only in increasing order, right? This process, suppose it has requested first resources of resource type R2, right? Then after that this process P, right, cannot request the resources of resource type R1, right? It can request only resources of resource type R3, right? It cannot request the resources of resource type R1, right? Because the process can request resources only in increasing order, right? Now let us see how this protocol can ensure that this condition, circular wait, cannot hold. Suppose that three processes are there, P1, P2 and P3, right? P1 is holding a resource of resource type R1, P2 is holding a resource of resource type R2 and P3 is holding a resource of resource type R3. Integer associated with the resource type R1 is 1, integer associated with the resource type R2 is 2, integer associated with resource type R3 is 3, right? Now suppose process P1 requests the resource of a resource type R2 which is held by process P2, right? And process P2 requests a resource of a resource type R3 which is held by process P3, right? Now for a circular wait condition to hold, this process P3 must request a resource of resource type R1, right? But this is not possible, right? If we use this protocol, then it is not possible because each process can request resources only in increasing order, right? So process P3 cannot request the resource of resource type R1 which is held by process P1, right? So this circular wait condition will not hold, okay, if we use this protocol, right? Now let us see the second protocol which will ensure that circular wait condition cannot hold. So according to the second protocol, if a process is requesting resource type RG, then it must release any resource Ri such that assigned integer of Ri is greater than Rj, right? Now see what happens in this protocol. Suppose there is a process P, and this process P holds a resource of resource type A. Integer assigned to this resource type A is 5. Now process P requests a resource of resource type B, and integer assigned to this resource type B is 2, right? So in this case, what happen? Process P has to release the resource of resource type A, right? Because in this case the process P is requesting a resource of resource type whose integer value is less than the integer value of a resource of resource type which the process P is holding, right? So in this case, the process P has to release the resource A.